Look at that. So, I want to welcome everybody to the NYC Complexity Lounge, which is a meetup where we gather to talk about all things related to complexity and complex adaptive systems. I'm Jocko Selberg, and in one of those boxes is the lovely and talented Barbara Frontera, and together we co-host the Complexity Lounge. Very quick, before we kick it off, just a few ground rules. We will be recording today's session, and so if you do not wish to be recorded, please make sure your camera and your microphone are turned off. And we also ask that while Abeba is speaking, that you please keep your chat activity to a minimum. But if you do have a question, we will have a question and answer period, but you can either raise your hand or just send your questions directly to Barbara via the chat, and we will collect them. And I believe Barbara has a request that maybe you put a Q in front of them so that she can identify them as questions rather than comments. That would be extremely helpful. So the recordings will be posted on our Vimeo NYC Complexity Lounge page in the next couple days, and that is where you'll find all of our past videos as well. So our guest today is Abeba Birhane. She is a cognitive science Ph.D. researcher at the Complex Software Labs in the School of Computer Science at the University College Dublin, Ireland. Her interdisciplinary research sits at the intersection of complex adaptive systems, machine learning, and critical race studies. She co-leads the Data Economies of Data Governance Working Group and is also a member of the Coalition for Critical Technology Group. She is currently a research scientist intern at DeepMind with the ethics research team. And today, Abeba, we hope, will be discussing how machine learning and artificial intelligence interacts with complex human systems. So Abeba, welcome to the Complexity Lounge.
Thank you so much for that lovely intro. And I should mention that I should have updated my bio. That's about 6 months old or even longer. I am no longer at DeepMind. I have also left the lab, and because I finished my PhD. So currently I am a senior fellow at Mozilla Foundation. Yes.
Awesome. Congrats.
Thank you. Let's see if this screen sharing works. Can you see my slides?
Looks good.
Yep.
Excellent.
Thanks for the chat, Dave.
Pleasure.
Yeah, I am under the impression this group is not your typical academic audience where where talks are super intense and scheduled and all that. Instead, it's a very relaxed environment where there is much more discussion rather than the speaker talking. So with that in mind, what I'm planning is to kind of talk for about half an hour. And if anybody has a comment or a question while I'm talking, please feel free to just interrupt me because this is not a super kind of tightly planned talk, but rather this talk is the first time I'm giving this talk because it's based on a new paper that we just submitted about a week ago with my collaborator, a professor of mathematics, where he does the modeling stuff and I do mostly the critical stuff. So it's the first time I'm presenting it, but it's also based on so many loose ideas. So I'm kind of gathering my thoughts as I go along. So please feel free to just interrupt me and comment if you have any comments. So I think it's become trivial to say that machine learning models are being used to that machine learning models are everywhere, and people are modeling complex adaptive systems using machine learning models, whether it's weather forecasting. DeepMind has achieved great success in what they call nowcasting, which is predicting the weather about 1 hour, maximum 2 hours ahead. You also find great success in building machine learning models for board games. Again, DeepMind is at the forefront of this. We also find machine learning models in biological systems. Again, I didn't know so many of my examples were from DeepMind, and as I said, I have left DeepMind. You also find within biological systems, another example is DeepMind's AlphaFold, but also you find machine learning models within the healthcare system in medicine. You find them within a much more social environment, which is using models to kind of decide or to kind of make prediction and decision about, for example, who should get, welfare benefits. Here is another famous example where we have used machine learning models to decide who is the most suitable employee. Amazon had, there was so much contradiction on that hiring algorithm. It's no longer used. Thankfully, it's discontinued. Also, we use machine learning models within the law. So these are kind of various examples to give us an idea of the kind of social, biological, medical, environmental spheres that we are using machine learning models for. And all those, I hesitate to say, but almost everything that machine learners are building a model for can be classified as complex systems or complex adaptive systems. So for the next few slides, I'll talk about the nature of complex adaptive systems, more specifically coming from what's called critical complexity, which Paul Cilliers popularized, but also I think Alicia Horero is also a fan of, but also from the perspective of what's known as inactive cognitive science, which I'm a big fan of. So according to those perspectives, complex adaptive systems or complex systems are always moving, always becoming, and never finished. A complex system is finished means it's come to a halt. That means it's basically dead. It's no longer a system. So that means these systems are not calculable. We cannot exhaust them. That means we cannot neatly categorize them, and which makes making predictive models impossible, very difficult, if not impossible. Taking some passages from one of the most influential work in active cognitive science, it's called Linguistic Bodies. And here they are more specifically talking about human behavior, human action, human cognition, which is undoubtedly a complex adaptive system. The emphasis the authors make here is that living bodies are never stationary; they are always moving. We cannot average them. We cannot capture them in a neat taxonomy. They are necessarily historical. They are embedded in the social, in the cultural, in the political sphere, and we are always contextual organisms. In the second passage, the point that needs highlighting is that there's some kind of misunderstanding within embodied cognitive science, which I would classify as, part of or a very close family to inactive cognitive science, And the misunderstanding is that is thinking of bodies, human bodies, as some kind of a dummy or a dead body, but rather human bodies are they are never stationary, and they have much more in common with hurricanes than statues, because as I said, we are never stationary, but always within context, always moving, always interacting. Again, I know many of you are a fan of Alicia Herrero, so am I, and this passage captures complex systems beautifully, which is that any complex adaptive system's precise pathway or precise future behavior is simply unpredictable because of all the factors I have mentioned. And it's not critical complexity without mentioning Paul Cilliers, of course. So keeping all that in mind, if we want to capture a complex adaptive system, the idea is that complex adaptive systems are so complex, moving, contextual, always changing. Any model we build will be just as complex as the system itself. Here, what we want to highlight is the fact that as opposed to clear distinctions, clear boundaries, and clear divides between objective and subjective, or body and environment, and person and other, what we constantly find is when we are dealing with complex adaptive systems, especially human behavior and human action, what we constantly find is uncertainty, ambiguity, and inconsistency. These really mark what is at the heart of human behavior. So the point I'm trying to get across through all these examples is that complex adaptive systems, on the one hand, are incompressible, which means that we cannot compress them into something final so that we can build models about them. But they are incompressible, continually changing, dynamic, and unfinalizable, unfinished. So building on that, this is taken from the new paper I mentioned at the start of just as I started talking. We still, even though complex adaptive systems are impossible to capture in a model or impossible to formalize, we still have to build models, and we still have to create boundaries. We still have to somehow take some things for granted, and some models are helpful. And as I mentioned at the beginning, take for example protein folding or board game playing, not other game playing. For example, games that require, say, physical activity. We are not there yet, so it's important to emphasize board game playing. We can see that there has been so much success, and within the paper I mentioned, I apologize. We classify machine learning models in kind of three broad categories. The first one is closed ML. As I mentioned, we have to somehow close complex systems in order to build models. So the first one is closed ML. The idea behind this is that we can use machine learning to kind of to learn from data, and we can somehow successfully close this open system, and we can still somehow produce a somewhat useful and helpful model, and we can somehow capture that complex system through a model. I'll mention examples in the coming slide. And the second one is what we call partially closed machine learning, where we use data to build model of that system, but also it requires a lot of parameter tuning or a lot of human in the loop, where we have a model that is using historical data or past data as input, but also that requires a lot of hands-on from humans themselves. And the third kind of machine learning is OpenML, and this approach is the data does very little, but rather the model developer or the model creator does a lot of the work. For example, deciding which perspective to focus on, or what the objective of the model is, or what element of the system it needs modeling. I think I have example. So again, these broad kind of categories of closed machine learning, partially closed machine learning, and open machine learning are not, there is no clear distinction, but these are rather examples that kind of emphasize, the idea behind these categories. So building models of board games is a good example of closed ML, because we can, again, board games such as chess or Atari can be classified as complex systems, somehow complex systems. If you think of complexity on a continuum where, a system is, less complex on the other hand, and it increases in complexity, where on the other hand, you have social systems or complex systems that are, very complex. You can think of board games at the beginning of the spectrum where they are still complex, but it's relatively easy to close that system. So again, board games is an example where we can kind of create the boundary. We can create a model that can learn by itself. I put this in a quotation mark, just based on past data. Partially closed machine learning, this includes models of, again, nowcasting, or, forecasting the weather for the next 1 hour or 2 hours. Here, we have, both data, but also we have the human in the loop, fine-tuning parameters and using various processes. In OpenML, my collaborator, David Sumter, is a big football fan. So a lot of his work revolves around modeling football games. So the example that we use in the paper comes from his side, from his experience or from his work, where you can think of football as open machine learning, where the modeler decides we have to have multiple models for this kind of system, and we can have a pitch view, society view, biomechanics view, or prediction view, and each model can be helpful, and each model can say something about the system, and each model can capture a snippet of the system, and that's all we can do when we are modeling complex system. And in this case, the emphasis is that the model is constantly open, and it's the human that's mostly deciding or doing a lot of the work, and using the data or stats or models to highlight the important aspects of that system. But on the other hand, we also have a lot of models currently that can neither be closed or that are neither partially closed or open systems. This is outside the paper, but from my previous work, where unfortunately we have there is a huge market for machine learning models that, for example, predicts emotion or gender or personality or dishonesty or anything like that. These are models that ought to not exist in my view, but I'll explain that later because there is no scientific backgroundings for them. And unfortunately, these are, again, on the increase. There is so much money going into them. You can see them being applied in hiring. You can see them being applied within the education sphere, where there is a lot of appetite and market for example, softwares that detect attention of students or that are supposed to detect dishonesty or if the student is cheating or anything like that. Again, I'll repeat, it's impossible to build models of that because there is no way to sensibly say this is what dishonesty is, or this is data for dishonesty, because these are phenomena that are inherently cultural, social, but also how we frame these things, and who is building the model, who is doing the modeling, who is asking the questions, hugely impacts this. There is, for example, take a model for criminality. How do you define criminality? Is it petty theft, or is it criminal? Is it wage theft? And if you look at the stats, you would find a lot of what accounts as wage theft is much broader. It happens a lot more than, say, for example, petty theft. But when we are modeling criminality, we don't usually go for who is guilty of, reducing minimum wage or minimum wage theft. We usually go for petty theft. So the point I'm trying to make is our stereotypical in social understanding is the models we build. Again, lie detectors, there is no scientific groundings. It's impossible to build models for, yet these are things that there is so much uptake, especially with the rise of machine learning models. Again, this is from a recent paper that we campaigned to get it retracted. Unfortunately, it wasn't retracted, where they're trying to build a machine learning model for trustworthy face. In a sense, this kind of current research that is being resuscitated by machine learning resembles very closely to what was physiognomy and phrenology back in the 40s, 50s, and 60s. And that kind of research has largely been discredited as purely pseudoscience. And also, a lot of the problems with these kind of models comes down to the kind of data we are using for our models. As you might all know, at the core of machine learning, what made machine learning, what made it blossom, what made it into a big thing all of a sudden over the last 12, 14 years is the availability. I say the availability in quotation marks, again, because it's not really available. It's just that data curators and machine learning researchers just decided to outsource data from the internet. So it became available in quotation mark without the consent or awareness of people that are putting up their data or their images or their text data on the web. So going back to my point, machine learning became popular due to, again, the availability of large-scale data sets. And these large-scale data sets are part of the problem. It's important also to emphasize that all our problems in the kind of issues I mentioned cannot be solved purely by fixing data. Again, I say this in quotation marks because it's impossible to fix data. But a lot of, any data set that's sourced from the internet always will have problems, always has problems. And a couple of my papers have highlighted this, and this is taken from one of my previous papers with a collaborator, Vinay Prabhu, where we examined tiny images. It was a data set that's been used for vision research for over 12 years, and nobody has audited it until we went in and took a look. And what we found, as you can see, is the data set contains so many problematic labels associated with individuals and groups of people. I won't utter out the kind of slurs or problematic stereotypes we found. But as you can see, the data set was really problematic. And eventually, using such data set to train machine learning models will have problems. That's inevitable. And thankfully, this data was retracted from MIT's library. This is, again, from a much recent paper that we released in October, I think, the largest multimodal, open-sourced multimodal dataset available. It's still the largest multimodal dataset available that's open-sourced. You can still go to the portal and experiment with the dataset. And what we found is beyond words. Unfortunately, the dataset still exists, and I don't think retracting it is the solution, but that's another thing. We won't get into that in this talk. But the point I'm trying to highlight is that these datasets really embed deeply held problematic stereotypes. You prop the dataset with the word African, what you find is a real old cliched image of African tribes. On the other hand, you type Europe, it's presented as if it doesn't have tribes or stereotypical understandings. You just find neutral maps, neutral in quotation mark. Just a couple more examples from that same data sets. It's called Leon 400 million. And when we typed in beautiful, what returned was a lot of image of women from pornographic sites. On the other hand, you type handsome, you find white men in shiny suits. The same for CEO. But on the other hand, you type terrorist, and you don't find the extreme right-wing terrorist that's killing a lot of, that's doing school shooting in the US, for example. But you find, the Middle Eastern, turban-wearing terrorist. Again, the points I'm trying to make is all data sets sourced from the internet are always problematic, and all data sets that we are using for machine learning systems are sourced from the web in one way or another. So we have a problem there. Again, if our data sets are problematic, then it doesn't make sense to think that our models will be clear from the kind of problems that the data sets are exhibiting. To think that is just a fantasy. And to illustrate that example, here is a couple of points. This model was released, I think, about a year ago, where the idea is in the first column, you have your image, and then in the second column, the model depixelizes it. The idea is that the model can construct what I might have or anybody might have looked like based on few pixels or based on depixelized images. And the reconstruction based on the ground truth, which is the middle column, is that an image of, in this case, in this instance, me, where my curly hair became straight, where my wide nose became, became much more smaller, skinnier, and where I became more like a man rather than a woman. The idea is that models do, directly or indirectly do pick up decolonial and white supremacist and racist and sexist ideas of what beauty is or what a person is supposed to look like. It's inevitable. Another example, again, me playing with OpenAI's Philosopher AI. I think you have to pay to prompt to use the portal. It's no longer free, but you type in what's the problem with Ethiopia or what ails Ethiopia, and what you find is so much incorrect and racist and stereotypical, mostly incorrect and false information about the country. So the model does represent, or the kind of text it's generating does represent a really sexist Western view of what Ethiopia is like, or how Ethiopia is understood. Going back to the problem of social systems and the challenges of predicting a social system, this is a really solid research which I encourage you to look at, where a team of 160 machine learning researchers each tried to build each tried to predict what's an outcome of children coming from underprivileged homes might look like, and they used data that has been collected by social scientists. And what they found was, out of the 160 teams, not even one could make an accurate or a prediction that's close to that kind of represents how the child, or how that those underprivileged families might have progressed, and the best model from these teams was performed a little bit better than the simple benchmark model. This is just to illustrate. There is also empirical evidence that it's practically impossible to predict social systems, and the more they veer towards the social, the more it becomes difficult and impossible to predict. And these predictions and these models and these attempts to capture, what human behavior or what a good employee might look like, are not just experiments in the lab, but they do have real life impacts. They do impact real people. Jobs are lost, or lives are lost, or people go to jail due to these models, because they are deployed into the real world. And when models fail, or they always fail, of course, and when things go wrong, you look at every problem with machine learning models, the recurring theme, something consistent you find again and again and again, is that people and communities and groups that are at the margins of society always pay the highest price, always are the ones that tend to suffer the consequences. Take a look at this medical machine learning. You find it's Black people, it's women, it's trans people, it's older workers, it's immigrants, people of color, LGBTQI, children, and the list goes on. And the point I want to emphasize is that it's always marginalized communities that suffer the consequences of machine learning models getting complex systems wrong. Here's another As example, most of you might have seen. When people point out problems, unfortunately, and it really frustrates me, a lot of the debate then goes into, if there is enough data, we will build better models, or the debate becomes how well is the algorithm performing or how accurate it is. And when we are talking about, this might be a question if we are talking about closed machine learning or partially closed or open ML. But if we are talking about, machine learning models where there shouldn't be any, this includes, gender prediction, emotion prediction, jade detection, or dishonesty detection, or anything like that, that will be considered, cheap AI or pseudoscientific AI. The debate shouldn't be whether it's accurate or not. It should be, these are complex phenomena that simply cannot be captured in models. And any model, any capturing we do, any model we build is guaranteed to really encode social norms, historical injustices, and what society considers as normal, rather than getting at anything fundamental or anything of essence. And unfortunately, the debate about how accurate it is or how well is it performing is, again, it costs, I call it cheap talk, because when your algorithm is found to be inaccurate, the price you pay is very little. It might be damage to a reputation, it might be criticism. Whereas, if you are at the receiving end of the decisions made by these algorithms, it could be discrimination, it could be inhumane treatment, it could be even days and imprisonment. So there is an asymmetry, there is an imbalance that this moving the debate towards accuracy and performance is bringing about, and that again is frustrating. I mentioned another paper of mine just to make the point, where we looked at 100 most influential papers that are published in the top machine learning venues, which are ICML and NeurIPS. And what we found was, out of all the 100 papers, most of them really care about performance. These are the values, as you can see. They care about generalizability, they care about novelty, they care about efficiency, accuracy, and everything state of the art. And none of them care about injustice or welfare of the person or anything like that. Out of the 100 papers, only 2 mention societal implications of their work, and one of them barely mentions it, just in passing, as you can see here. So unfortunately, people do think of these completely wrong and dangerous models in terms of how accurate are they and how can we make them better performing, as opposed to thinking these models are inherently wrong and dangerous and harmful to marginalized communities. So I'll leave you with a final point that I hope this talk illustrates, which is that the more phenomena resembles to, the more it's grounded in sociality, the more it's embedded within relationships, within culture, the more it's grounded in history and norms, the less capable a machine learning model is in capturing it or in making any predictions. And also the more dangerous it becomes if we just go ahead and build the model anyway. Hopefully that makes sense. It's kind of an assemblage of my new paper that should be coming up soon, but also a lot of my past work. So I'll now open the floor for questions and suggestions and comments. The paper is work in progress, so any comments is welcome. Are welcome. Thank you.
Well, thank you, Abeba. That was awesome. Sandesh has a question. Do you want to unmute? Abeba, if you stop sharing your screen now, then we can. Yeah. Sandesh, do you want to unmute yourself or do you want me to ask the question?
That's fine. I can ask it. So my question essentially is, what is your opinion on autonomous driving and how some of these issues might play out in that sphere?
That is an excellent question, Sandesh. Autonomous driving, Melanie Mitchell in her book, I think Understanding AI, I can send you a link. It's a brilliant book. Gets into the whole area of autonomous driving, and she even provides various classifications of autonomous driving, where I think she has about five categories. Where on the one hand you have, or you can think of it as a continuum. Where the human takes a lot of control, and you can still consider it. I think this is what we currently have with Tesla and others. It's still very much so much human in the loop, and the human still does so much, contributes so much to the so-called quote unquote autonomous vehicles. Fully autonomous vehicles, which Melanie Mitchell classifies as, I think, like level 5 or something, is probably impossible. If it's possible, it's far, into the future. This is what you can think of this as, a closed email, and trying to build a model or trying to have an autonomous driving that is completely closed, is that purely learns from data, and that where you can have clear boundary, is really difficult, because you are dealing with the real world, you are dealing with the physical world. It's one thing to build a brilliant model for Go, for some kind of board game, because there's not because you are dealing with simulation, because you are, again, you can build a simulated model. You are dealing with the virtual. But when you are when you are thinking about autonomous driving, you really are out in the world. So you are dealing with constant ambiguity. You are dealing with the physical world. It's not just software, it's also hardware. So it becomes really difficult. And I guess the first point I want to make is that the very idea of autonomous driving needs a close scrutiny, because what we often consider autonomous is not really autonomous, because there is so much human involvement. And purely autonomous driving may not be possible. And if it's possible, it's far ahead. Having said that, there are so many elements to autonomous driving. And one element I have looked at in the past is, autonomous driving needs vision systems. And I've worked with computer vision researchers. And I think of my work, partly within the realm of computer vision. And it's interesting, a lot of people think of autonomous driving, and the ethical questions that immediately come up is, the trolley problem. With the autonomous driving, will it have to choose to save the driver, or the people out on the road? How do we solve this ethical dilemma? This really shows like a lot of the AI ethics or machine learning ethics really is involved with first world problems, with really like hypothetical thought experiments, because when in reality what you find in computer vision, because you need to recognize environment and people and pedestrians and cows and boogies or whatever, because you need to train your system to recognize the visual environment. And what you find when you are doing that is that vision systems recognize darker skinned people way less accurately. So all that like thought experiment about who is going to be saved and all that just shows that you need to think of historical injustices. You need to think of critically about who's being considered a person, because what you find, what this research found was that vision systems that are implemented in those self-driving cars, in quotation mark, were unable to recognize darker skin colors. Again, this goes back to my point that individuals in communities at the margins of society, no matter what the machine learning application, always pay the highest price. So I've tried to address two elements of self-driving cars, but there are so many perspectives that you can approach it from. And I hope that answers your question.
Yep, thank you so much.
And that's all before, as Melanie Mitchell points out, before you get involved with like the interaction of that system with the legal system. You know, who's driving the car? Who's responsible? Who, there's a case that's making its way through the courts here with Uber, where one of their self-driving cars hit someone. There was a person in the car, he wasn't paying attention. So Uber was actually driving the car, if you think of the algorithm as being part of Uber, but do we charge the person that was there with manslaughter? Was the legal question that started to come out of all of that. So it's really rich when you think about the interaction of these various complex systems, even in a single incident.
Exactly, yeah. And we have, again, another problem with the machine learning AI discourse is we often think of machine learning systems as way developed than they actually are. This is part of the overhype and overpromise that we keep hearing, but in reality, the current state of the art, machine learning systems, take for example again, vision systems are, way incapable of so many of things that we assume they are capable of. Taking another example from Melanie Mitchell, you might take, for example, this image where you have, a man and a lady pushing a trolley with a baby in it, and she has a dog on the other hand, and the man you can only see because lower part of his body is covered behind the trolley that she's pushing. You can't see the lower, it's not visible within the image. And the point that Melanie Mitchell tries to make in that image, in that picture, is that for the human, we know because we have background knowledge, because these are things that are taken for granted. We know, even though we can't see the man's legs, we know that there is a human being and he has a leg. Whereas vision systems, on the first instance, vision systems suffer recognizing multiple objects in a single image. They usually are really good at recognizing just one thing in a given image. But second of all, these background, taken for granted knowledge that the man, even though we can't see the lower part of the body, he's still there, are things that are really difficult to teach computer vision systems. Again, so the point I'm trying to make is the systems we have are not as advanced as we often hear them or we often make them out, and it's just overhype and overpromise. Again, if you follow me on Twitter, you might have seen my constant rant about that.
Yeah, that's very entertaining. Ben has a question. Ben Mosier has sent a question. He said, given that machine learning models will be flawed and accuracy is the wrong thing to focus on, it sounds like the important thing is the consequences of model use, and use is in all caps. What behaviors would you expect to see more of if we were giving those consequences the attention they deserve?
Yeah, that's an excellent question, and focusing on consequences is a good thing. However, we've seen, so I have audited, at least 3 large-scale data sets now, and what you find is the same thing. There is always stereotypes, there is always slurry labels attached to people. there is always content that shouldn't be there. For example, explicit pornography. You find images of children, inappropriate images of bodies or anything like that. So I know by now that any large-scale image datasets that's sourced from the internet will have, without doubt, problems. So we shouldn't wait for consequences. We shouldn't wait for someone to go and audit and look at, again, for example, datasets, large-scale datasets, to say, oh, here's the consequence, we should do something about it. We should know, given what has happened in the past, using again large-scale datasets as an example, we know we can guarantee that there will always be problems. So for me, I would emphasize that we should assume and work from the assumption that these large-scale image datasets are problematic unless and until someone goes in and does some kind of mitigation. It could be, filtering out some content. It could be, diversifying datasets, or it could be anything, any measures. So we should work from the assumption that the consequences will always be bad, especially for marginalized communities. And because we have had enough evidence, we have had enough data, we've had robust research that highlights that the consequences are often bad. So we should, I think we've had enough consequences. We need to take the assumption that unless things are, looked after, unless mitigations are in place, unless regulations and legal policies are in place, where we keep repeating we keep finding the same problems again and again and again. And this is my, again, frustrated personal view on the matter. Not many people would share this, of course. Any more questions, comments? I'm not looking at the chats.
Yes, the chat is super interesting. But also, for me, one of the most interesting things about all of this is that there's so much of this that we don't even know is impacting our lives, right? It's completely behind, it's a black box. And I have no idea, why my credit score is what it is and whether it's lower in relation to everyone else, and why, until you see an example. Gianni has asked, what research is there on potential mitigation of these issues that you brought up? The racial bias.
Mitigation.
Gianni, unmute yourself and join in. Come on, you want to.
Yeah, well, I guess we know the data. There's problems no matter what. We assume that, and we don't assume. We know from the research that certain communities are going to be negatively affected by the use of whatever kind of automated whatever pulling from the internet. Is there any I don't know, in where there is data being used, knowing this, what kinds of mitigations, is there research on any kinds of mitigations that can be done, that can work, that might work, any testing, in what kinds of scenarios, what kinds of uses of applications? I think that would be interesting to know what's out there. What are people thinking, and what are they trying to do? So there are various mitigations that have been proposed by various people, and I'll answer your question in relation to what I know, which is mitigation for, say, bias or problematic content inclusion within datasets, because that's what I'm most familiar with. And there are various technical solutions and mechanisms and methods are in place, and for inclusion of problematic content, for example, we have the C4 data. It's a huge corpus where Google researchers basically just created a long list of words, keywords that should just be, based on those keywords, it should just be, excluded. I won't say any of the words because they are offensive. You are working in these areas. You are always, navigating how to talk about, problems in dirty data sets. So I'm still navigating that space. So I won't say the words within that key list. But that was one of the mitigations, because then words that are within that list can be excluded. So on the surface, that was a good mechanism, and a lot of people adopted it. But the thing is, this kind of problems it's like whack-a-mole. When you mitigate for something, when you cover something, another problem pops up. And what they found was that in that huge corpus, in that huge that C4 data set, a lot of words were unfairly censored. For example, words in terminologies African Americans use, websites from rapping lyrics websites, or words and kind of language that's used, for example, by the LGBTQI and queer community, language they use to communicate about, sexuality and intimacy, and all those words were unfairly censored. And again, what you find is one mitigation, which is, keyword censoring, worked in kind of excluding problematic content, but it also unjustly censored, overly censored marginalized communities. So I guess what I'm trying to say is there are various mitigation mechanisms and solutions, but because this is a really messy area, they all have issues that come with them. So we can think of mitigation mechanisms, but we have to be careful about getting the idea that the mitigation mechanisms will magically get rid of all our problems. No, it's related to historical injustices, the history of coloniality, and the history and society itself, and how it treats certain individuals based on their privileges, in a much better way, whereas other individuals in communities, social structures impose obstacles to those individuals. So it's social structures, it's unjust histories, it's the history of white supremacy, all those which are very broad, very difficult to pinpoint, to measure qualitatively, but the problems with data sets and models is not something that can be fixed with magical mitigation solutions, but they go all the way back to these very broad issues, societal issues. Andrew, you have a question? I see your hands raised.
I do.
Yes, Andrew first, and then we have some in the chat as well. So go, Andrew.
So there's a little bit of a lead up to the question, so bear with me. I'm going to try and give you some context for why I'm asking it. So okay. I've been working on a personal project with, kind of an advisory group that's working in community and workforce development. And it's in the context of the New York cannabis regulations that are coming. So it's been legalized, but the regulations are going to be out in about a year. Mm-hmm. And the idea behind this work is to structure the financial gains to be kind of redirected into the marginalized and disproportionately affected communities that have been affected by the drug war here, as opposed to kind of these rich white MSOs that come in and try to kind of control everything. and make these big plays for power. So one of my potential funding partners is very interested in the idea of utilizing data science as a mechanism for empowerment and growth. And it's particularly valuable here because a lot of the disadvantaged groups may not have the systemic advantages of data science, training, knowledge, connections. And this industry in particular, from its traditional roots and these people who have been disproportionately affected, have had intentionally poor data management because it was a liability. So there's like some things here, there's a lot of room for growth. So how do you see machine learning being utilized in a proactive fashion? Because we've talked a lot about kind of mitigating the damage that it's doing. But what do you think about proactive utilization, specifically in the context of empowering marginalized communities in this type of a context?
Yeah, thank you for that, and thank you for that background information. It's really helpful, contextualizing your point. I guess what comes to mind is, the motto, "Nothing about us without us." This was popularized by the disabled community back in the 70s. So yeah, a way forward would be to kind of build on that principle. If the idea is to help and to kind of uplift and to bring advantage to marginalized communities, they have to be at the forefront of, what are the important questions that are affecting us that need answer, not, questions set out by the privileged folk, because, if you are privileged, you are blind to, to the questions that are impacting people, because you really, if it doesn't affect you, you can't see it, that you literally, it's a blind spot for privileged folk. So it has to come from those marginalized community. It has to be a concern for them, not a perceived concern for the data scientists or the developers. It has to be built by them. And there are so many examples that are actually doing this. So Data for Black Lives, this is led by Yeshimabet Milner. It's an excellent example where they are using data to kind of highlight injustices. One of their projects is to show that, problems associated with childbirth, especially stillbirth, affects Black women way more than white women. And, if you have the data, they've been gathering the data, then you can go on about solving it. You can go on about mitigating it. Another is, the Justice League. There are so many, especially in the US, there are so many projects that are examples in this case, in this instance, that are led by mostly Black women in marginalized communities, that are showing that, data science and machine learning can be utilized in a way that's beneficial to marginalized communities. Hope that answers your question.
Thank you.
So Mark Borgauer, you put a question in the chat. You want to unmute yourself and interact with our guest, or do you want me to read it?
No,
hey, Mark.
There he goes. Yeah, I knew you'd get
nice
in there.
to see you.
So, I've been a fan of your work for a long time. And also, thanks to you, also got attention from a lot of your peers. And so from the outside, it feels like you're fighting an uphill battle. So I was curious, what can we non-experts who don't have the time to acquire the expertise required to really take these models apart, etc., the way you do, what can we do? Is there maybe something in the way we're using data day to day that we should be aware of, that we could do differently, or guides or norms, or so that we should adhere to, or also tell other people about, so that it becomes less of an uphill battle?
Modest
and very modest and a nice question. Yeah, I guess so. I've seen myself as a researcher in the past, where I would, I don't know, maybe run experiments or do audits or whatever, and present a peer-reviewed or scientific papers like, here, look, it's horrible. But now, especially, over the past year, I've found myself that that's not enough. You have you as I mentioned earlier to Taine's question, you look into a model or a data set and you find, the same expected problem, and it's the same thing again and again and again. So, and unfortunately, there is no one single thing that anybody can do that will make things better, but it's an uphill battle that needs to be fought by so many different people, so many different bodies. It requires attention from regulators, policymakers, and governance people. This is a new area that I'm venturing into, that I'm getting into. But it also requires by machine learning experts themselves to really know their histories. Because if you look at the history of, for example, physiognomy or phonology, you will realize that it doesn't matter how accurate your emotion detection system is. It's just, it just rests on a false unscientific premise. So don't build it. It also requires, the general public, some kind of awareness that, any selfie you take and put on the internet, it's very likely to end up on some huge, large scale data sets. So know your rights, know how to demand for your data to be withdrawn. And also knowing your rights is not enough, because at the moment, even here in the EU, where you have GDPR, where there is clear statements that say, yeah, you have the right to withdraw, your data. At the moment, it's really difficult. You have to go through so many loopholes, and you have to know so much technical stuff to even ask for your data to be withdrawn. So what I'm trying to say is, it requires work from so many different bodies, so many different, organizations and communities and societies to tackle the various problems. Also, the problem is not just a single problem, it's layers and layers. Privacy and security people work on a set of problems. If you are an audit researcher, for example, like me, you are focusing on say, for example, problematic data sets or inclusion of problematic content. If you are a complexity researcher focused in machine learning, which I also consider myself, you are working on how it's complex adaptive systems are inherently you cannot capture the entirety of the system in a model. You might capture a snippet of it, and that might be helpful, but it's impossible to capture because these systems are incompressible. So what I'm trying to say is, any angle you are working from, you are dealing with various problems. So there are so many layers and so many various problems that we need to tackle, and tackling them is not an issue for some, a single body or a single individual or a single community, but rather something that requires input at so many levels from different people, from different organizations.
Thank you.
You are on mute, Barbara.
Damn it. Let's see. Sandesh has another question, I believe, somewhere in the chat. Sandesh, are you still with us? Okay, what does he say here? Question. Just qualitatively comparing a result derived by a machine learning model, given all these biases, to that of the average human, given their biases, would machine learning still be better? Oh.
Okay. The really not so well behaved, snarky me would ask, what's an average person? But I won't do that. I'll be nice. Yeah, so this is one of the questions that actually, that you hear within the machine learning, community. Is bias from machine learning systems really so bad or worse than bias from humans themselves? As I snarkily try to mention, there's no average person. You can't average humans. But even if we assume that, even if we can grant that, there are so many different humans, and there are so many different biases, and my bias may impact one individual or a bunch of individuals or a group of individuals. My bias won't be something that will be automated and applied into the masses. So one of the differences is that human bias may impact, I might treat you badly, based on your my wrong stereotypical assumption and my wrong understanding of, what you might what you might be like. But that might just impact you or the people that come across me or the people that, that my decision impacts. Whereas bias or problems in machine learning systems, it's deployed at a mass scale. And another element to this is that because there is maths involved, because there is algorithms involved, and because there is machine learning involved, people tend to treat those systems as objective and neutral. So even a lot of those biases are unlikely to just go unnoticed. So I hope that answers some element, some aspect of your question, Sandesh.
Yep, thanks.
Great. Bao, you have a question. Do you want to unmute and ask it? Are you going to make me read this?
Sure. Yeah, okay, sure.
Good.
Thank you. Thank you, Abeba, for your inspiring presentation. So trying to just synthesize what you've said there, if I synthesize it, summarize it as follows, that essentially machine learning is deeply rooted in cause and effect reasoning. And when applied to a complex issue, its application is always flawed. And therefore, we should approach it with deep suspicions.
I'm not sure I would go so far as to say that machine learning is rooted in, cause and effect reasoning. I don't think I don't think I would agree with that view. If anything, machine learning would, you give it huge amounts of data and it can kind of cluster based on similarities in patterns without necessarily telling you any causal relation or any reasoning behind it. So to your first point, I don't think I would go to call machine learning a logic rooted in cause and effect reasoning. And what was your second point?
Well, so then is it then that the human beings want to use it then as a cause and effect? Say, okay, this is the data set, we have processed all this, now because of this, I want to do this. Is that whether then the flaw is?
So causality is not really my expertise, and I guess one of the flaws is that this has happened in history in the past. So yeah. People have done these such and such things in the past. Or take the Amazon hiring algorithm, for example. People of this demographic, of this gender, of this sexuality
of this geographic location have been successful in working in Amazon in the past. So we will use that historic data to kind of build a predictive model of who is likely to be a good employee or who is likely to be a successful employee for the company. So in that case, what they found was that because the historical data is really, biased and problematic, the model that they're using to hire people was deeply flawed. It was excluding women candidates based on, keywords such as, any mention of women or any mention of femininity, their CVs were being excluded. So in a sense, maybe there is some sort of causality in a sense that, this is what happened in the past and this is what will likely happen in the future. And that sort of reasoning and that sort of thinking is deeply problematic.
Okay, thank you.
For me, one of the most interesting things is also how the use of these systems is changing the behavior of the system, in subtle ways that we don't necessarily recognize. But in the meantime, Bernard has a question. Bernhard, rather, I'm sorry.
No, Bernard, thank you.
Sorry.
Thanks. Yeah, I was just wondering, also connected to the last question, what I observe, what you're talking about is flaws that are maybe not so much in the data crunching itself. Machine learning and this large amount of data, now we're capable of doing something with that, but actually in the model that is behind it, the quality of the data, the way you have illustrated it. And I wonder to what extent both the fascination with this shiny thing that we have, and then always going for a big result, like predict, take away the decision from me and do it in my stead and better, is kind of something that has happened also before and outside of machine learning. I was thinking, and actually, Dave is in the call here. He has his gripes with that as well. When you think about, models of personality of any kind, I think most of them officially say this is not for prediction of performance, but everybody wants to use them for prediction of performance. And so they always go for something. And if you tone down the claim and say, what do we do? And maybe we don't predict, but we give an indicator to expand your attention to some things that maybe you might not be aware of. We can't say whether you'll find something, but we can just say, it's worth looking, or it's worth being careful about that part. So that if you actually tone it down and be less fascinated by this shininess of the thing and be more careful about everything, all the assumptions behind it, then it would actually not be that bad. Could it be that then machine learning is just a version of a kind of, it's like society is rushing forward to something, and there are the Cassandra voices, which I think probably all here in the call count ourselves to, that have to be, to say, be more careful. But if you tone it down, then it's actually, it could be much more dangerous and much more risky.
Yeah, I think I agree with your assessment of, machine learning maybe not being so new, and theories of personality and models of personality that have existed before the popularization of machine learning, maybe they are doing something similar to what machine learners are doing now, but I think there are a bunch of differences. So one is that say take theories of personalities, there is within that research, there is always existed, tensions and push and pulls. People would put forward theories of personality, and you would find just as much theory or work criticizing or, pushing against it or debunking it. So there was much more balance. Even now, within psychology that deal with theories of personality, you can say that that tension still exists. It's not just like here's theories of personality without a question, but here's a theory of personality with so many criticisms. And also theories, again, I'm focusing on theories of personality. It didn't have so much uptake, and it wasn't applied on a mass scale. Whereas with machine learning now, first of all, we've lost that critical faculty. If it's a machine learning model, people tend to, oh, wow, it's magic, so it must be doing something right. It must be great. So even within the machine learning community or the general public, there is very little, critical appraisal, and so much just, blind faith that you don't see within, again, say, for example, theories of personality. So it's, it's this lack of critical thinking and the huge scale that machine learning approaches to complex systems that differs from, what has existed in the past. That's my view, at least.
I think there is I've heard it from Daniel Schmackenberger. I don't know whether he's the author of that, but kind of this assumption that because the possibilities of choice making and impact are so big, there is more disregard for the sloppiness of sense making that is behind it. I wonder whether this is your observation as well. That it's more shiny because it's so big and impactful, and therefore we are less critical in our thinking behind it.
Yeah. And also, we go through like the AI winter, the AI spring, and the AI summer, and so at the moment, I think also, researchers like Melanie Mitchell would say that we are currently at the AI summer, where everything is great, where people tend to put so much faith in AI systems and little critical thinking, and it's a shiny state-of-the-art model. So let's just go ahead and adopt it blindly. So it's also that phase we're in, where both experts and non-experts and people within and outside the field are engaged in much more just believing without critical questioning, and this might eventually lead to the AI winter. Who knows?
Thanks.
Well, that is a function as well of the way it's sold, right? It's also save time, save money, right? If you see it in sort of the application in law enforcement, right? Like, we can get to a result really fast, if we use a combination of ML and facial recognition, which is the new darling of all of this. And it's also sold as scientific. When you have a system that is problematic and you tell, we're going to be scientific and use machine learning, it's very seductive.
Yes.
It's very seductive to think that this will solve the problem of human bias and solve the and so there's layers of this within, and that's what I was trying to get at before when I was reading an article about the use of facial recognition in law enforcement, and they were sort of saying how, even when they talk to witnesses now, the witness will say, well, I saw the guy do it and he looks just like Jocko. But then they use facial recognition on some blurry, photo from the camera, and they present the same witness with the photos that the system came up with, and they will pick one of those photos even though it isn't the person they described. So it's the combination of our already existing bias and our already, the idea that if you're presented with a bounded choice, you often find the answer within the bounded choice, right? And that's what this is sort of doing to an already problematic system. So, Dave, we've been talking a lot about stuff that's just in your wheelhouse. Do you have anything to say here? Is he left?
I still see him.
No, I'm on mute because I'm in the middle of the Lake District on a walking holiday, so reception is brilliant. So that's something going, and I thought I'd confess to the indulgence.
Well,
Thank you for coming, even though you are on a walking tour. So
no,
yes.
Literally, when we were waiting, everybody's neglected training data sets from the word go. And one of the things we actually worked on 20 years ago on DARPA is we said you have to start with the training data sets, not.
Yeah, I think he's cut out. Yes, Dave, I've been following your walking holiday. I've been following your walking holiday on Twitter, and it makes me tired. You're back. Okay.
So two things. First of all, I think you start with the training data sets, not the algorithm. I think people have got it asked about face. I think secondly, diligence into the training data sets, which isn't just exemplar based, but is actually interpretive. So that's one of the things we do with SenseMaker, is to create high abstraction metadata. And I think that links in with the epistemic justice issue. Which is critical and radical, not just contribute their experience to a machine. So the interpretation for me is key.
I think we got about a third of that, Dave. But it was interesting because some of the summary stuff.
Cut in and out.
Yeah, we got enough, I think, to get the gist of that. Our response, I mean, basically kind of similar to what I was saying, is doing mass pattern recognition on inherently flawed data, because the data is actually created by people. It's a circle that you're trapped in, but it gives the illusion that, as Barbara was saying, is that it's somehow scientific and objective, right? And so we're stuck in a riddle that we can't get out of.
Yeah, this is all. Now, Abeba, let's make sure that everyone knows where they can find your work.
Yeah, so most of my papers are on Google Scholar. So you can type my name and Google Scholar should bring out my papers. I'm also on Twitter, mostly just ranting and complaining. So this is your warning.
But in a super interesting way. I mean, the rants, I love a good rant. And your rants are you know, I mean, they're ranty rants, but they're very good.
Thank you. Thank you.
And I love your book whenever you do one of your book readings. You know, that's my other favorite thing on Twitter, when you're reading a book and you sort of give us a long thread of a breakdown. Your Cilliers breakdown was one of the best ones I've seen.
Yeah, I like doing those because it also kind of disciplines me to read books in a certain, in a consistent way. But also, I also think that, these are books that people should know about. So I also see it as, as a service that popularizes critical work that goes against the hype of machine learning. So I'm glad to hear that people do pay attention and people do enjoy those book threads.
Yeah, they're great. Now, the other question I wanted to ask you is, as we're exploring all of these things, who else would you? I mean, we've given everybody where they can find your work, and who else would you recommend people look at as they try to explore this in terms of, the complexity and the complex adaptive systems that we like to discuss here? We mentioned Melanie.
Yes.
Who else you got?
Melanie Mitchell is brilliant. And she was my external examiner for my PhD Viva, and she was very kind, also a nice person. And I think most of you are familiar with Alicia Horer's work and Paul Cilliers. So those are kind of my go-to critical complexity thinkers. As you are all aware, complex systems or complexity thinking or perspective, whatever you want to call it, is also like very broad and sits on a huge spectrum. you have the super physicsy focused Santa Fe style complexity, where they deal mostly with physical systems. But on the other hand, you have critical complexity who try to bring, values and norms and injustices and power asymmetries into the equation. So they're all helpful depending on what you want to get out of your perspectives or your theories. So my go-to complexity thinkers are people like Alicia Herrero and Paul Cilliers, mainly because they pay attention and they emphasize factors that are often ignored by complexity thinkers, factors such as the impact of social injustice, historical injustice, and power asymmetries and all those important factors.
I was also thinking of those two women that used to work at Google.
Those are
Mitchell.
more of
Meg
Mitchell and Timnit Gabru. They are more on the ethical AI side of things than on the complexity side of things. So mostly Black women working on the ethics of AI. There are so many of them. They find them on Twitter, and they are often
Rua Benjamin and these are all people that they talk. They're involved with the ethics of AI, but that touches on this whole complexity thing because ethics are complex. Ethics are complex. Yes. Ethics are complex in human systems, and then when you add in sort of machine learning actors, you've got a whole other system floating around. So this is an area that's long fascinated me because of this idea of actors in a system, some of whom are human and some of whom are not, and what those interactions look like.
Yeah, exactly. Yeah.
So yes, Bernie Kahn dropped the link for the Algorithmic Justice League, Joy Buolamwini's organization. So they're all out there. They're out there, and people are talking about this. It's just that, as Bernhard said earlier, the shiny object syndrome is still there. Mm-hmm. That this is going to solve all our problems. Here in the U.S., there was just a big outcry because the IRS, the Internal Revenue Service, was going to use facial recognition in order to let us file our taxes online. That went well. But then it turned out that there's about 20 states on the state level that are already doing this. That in order to file your state taxes, you have to submit to this facial recognition system. This is all filing it online. Yes, and Mark dropped in the Santa Fe Institute journal article in the chat.
Mm-hmm.
It calls into, you'd mentioned ethics and justice and all of that, but all of these are built on assumptions, and just the deep dive rabbit hole of what is assumptions and how do assumptions actually operate on a cognitive level is it's bottomless pit. And all of, but it's such a central core aspect to human beings because you can't operate without them. Right? There's just no way that you can process information without assumptions. So it's both a survival mechanism, inherently useful, but also it leads to our own downfall, particularly when we start to engage or attempt to create very complicated systems to inform us further, because those assumptions get deeper and deeper embedded until it's assumptions all the way down. So it's interesting.
Yeah, exactly. Yeah, this is what I tried to mention earlier. We have to start from somewhere. We have to take some things for granted, and we have to take some assumptions for granted. This is where the some things can be, you can say this is a safe assumption, and we can, even though it's a complex system that's continually moving and dynamic and changing, we can kind of close it down and build a helpful model. This is, the example of the board games that DeepMind is advancing, because there is not so much morality or value judgment involved in those. Your assumptions are safe, and you are able to somehow build a helpful model for those complex systems. It's just as when you venture more towards the social side of things, that if you don't question your assumptions, or if you decide to kind of say, this is the kind of boundary I'm drawing, this is where I'm saying, this is inside the system and this is outside the system, you can never be sure that factors that you thought are important and should be part of the system are in fact, necessary for the system. And you cannot also be sure that the factors that you've excluded as outside the boundary of the system, you can never be sure that they are in fact, not important or not necessarily or not relevant, because these are really social, complex, messy, ambiguous things that I highlighted at the start of the talk.
Well, it's worse than that, because your assumptions are also temporal. They change in time, and to keep all of the stuff that you described all in your head all at the same time, is it, if you have a safe assumption now, is it going to be a safe assumption once you start using that data for something else? And to track all of those assumptions while simultaneously developing new assumptions is just an impossible task, right?
I agree.
Well, that made me tired. Yeah, this is, and unfortunately, as you start to examine, Mark asked the question about how we can be more responsible with our data and things like that, but increasingly it's just algorithms all the way down. Every step of my life, as I execute my work, or I try to even purchase something, whether online or in a physical store, I'm creating these massive quantities of data that I have no control over unless I never purchase anything again or go anywhere. But even
and they're long lived. Yeah, they live forever.
Yeah. And and they are defining me in a way that I may or may not agree with.
Yeah. And the thing is, it's not inevitable. We may not have control over our data, but we should.
Mm-hmm.
But currently the norm shouldn't be the norm. We shouldn't accept it. It's not inevitable. We should.
Yeah,
this is where we need to be aware of, the legal system. This is why I'm venturing into regulation in policy, because, nothing is inevitable. We can challenge it and change that. This is the difference. Cynicism and criticism, where the cynic might be, not much you can do, and you just sit. Whereas criticism is, constantly trying to change, doing something about it, caring about it, and wanting to change something about it. This is why we are critics, not cynics.
Well, but it's a fine line. I could slip over like that. It could go south very quickly.
I hear you.
Does anyone else have any questions? Because Jocko and I could talk to Abeba all day long. So, and just bore the pants off of all of you. Anyone? Going once, going twice? Okay, Abeba, thank you so much. We really appreciate you coming in and talking to us about all of this. We are always grateful to hear other perspectives and to hear about different approaches to complex adaptive systems and the things that are interacting with them all the time. Thank you to all of you for sticking with us. We really appreciate it. Go find Abeba's work. You will not be disappointed. And I can't wait till you come back and tell us we can call you doctor.
No, I am a doctor.
Oh, they already, okay. I wasn't sure they confirmed yet.
Okay.
Oh, yeah.
Okay. So I can refer to you now as doctor. I'm very excited about that. You should change your Twitter profile. It would make them all go nuts.
Yeah, I should.
They hate that shit. But thank you so much.
It's been a pleasure. Thank you so much for inviting me. I've really enjoyed all the discussions and all the conversations. Thank you so much. It's been fun.
Thank you. And thank you to all of you. Dave, go walk some more because I see these things on Twitter and you're tiring me out. And all of you, we will be back in I believe April 11th with Jim Benson and Tony Ann DiMaria to talk about the complexity of collaboration.
So time had by all.
Yes, indeed. So put it in your calendars and we'll see you all soon. Bye, everyone. Thank you.
Cheers.
Bye. Thank you.